Hello students, in this video we will practice few questions on projectile motion. You can see here a ball is thrown from point O with initial velocity u. This velocity is resolved in two components, the x component and the y component. X component is u cos theta and the y component is u sin theta. At maximum height, the y component is 0 and the x component is u cos theta. This is the maximum height gained by the projectile. OB is the range of the object, that is how much horizontal distance the object can cover with initial velocity u. So let us start the questions. This is the first question. We have to find the angle of projection at which the horizontal range and the maximum height are equal. As we have seen in our previous video that the horizontal range is given by u square sine 2 theta by g and maximum height is given by the expression u square sine square theta by 2g, where theta is the angle of projection, u is the initial velocity with which the object is projected, g is the acceleration due to gravity. And in the question it has been told that the range and the maximum height are equal. So let us keep them equal. U square sine 2 theta by g is equal to u square sine square theta by 2g. See, u square is common on both the sides, so let us cancel it. G is also common, that is also cancelled. We can write sine 2 theta as 2 sine theta cos theta, which is equal to sine square theta by 2. Now let us cancel sine theta from both the sides. Now we are left with 4 cos theta is equal to sine theta. Rearranging the terms, we will get tan theta is equal to 4, or you can say the angle of projection is tan inverse 4. This is the required answer. Now let us attempt second question. A boy stands at 78.4 meters from a building and throws a ball which just enters a window 39.2 meters above the ground. We have to calculate the velocity of projection of the ball. See, here the word used is just enters. That means this is the maximum height which is gained by the ball. So we can understand it like this, that suppose this is the building, this is the ground, and the window is at 39.2 meters above the ground. Let us suppose that this is the window and the height of the window above the ground is 39.2 meters. And the boy is standing at 78.4 meters from the building. Suppose that the boy is standing here at point A, which is at a distance 78.4 meters from the building. Now from here the boy has thrown the ball which just covers this window and it reaches to the other side of the building like this. Now let this point be represented by B. The initial velocity with which the ball is projected, let it be marked as U, and this is the direction of the velocity. Now as it is given just enters, so we can say that the maximum height which is gained by the ball, which is given by the expression u square sine square theta upon 2g is equal to 39.2 meters, and AB is the horizontal range. And now you can look carefully from the figure that horizontal range will be twice of 78.4. So it will be equal to 2 into 78.4 meters. As this window is at the center, the object, the ball, will be covering AB distance to touch the ground. This horizontal range expression is u square sine 2 theta by g, which is equal to 2 into 78.4. Now we can divide first equation by second equation. Let us do it. U square sine square theta upon 2g is divided by the horizontal range expression, so it will become u square sine 2 theta in the denominator and g in the numerator, and on the right hand side we will get 39.2 upon 2 into 78.4. Cancelling the terms, we will find this, that is sine square theta upon 2 into sine 2 theta is equal to 1 by 4, because this will cancel by 2. So now we are left with sine theta in the numerator upon 2 into 2 cos theta, because what we have done with sine 2 theta is we have written it as 2 sine theta into cos theta, and sine theta terms are cancelled from the numerator and denominator. So we have obtained 1 by 4 tan theta is equal to 1 upon 4, that is this term. So what we are left with, tan theta is equal to 1. That means angle theta is 45 degrees. Now let us calculate the velocity of projection. For this, we have just calculated angle theta as 45 degrees. Use it in any of the equation, either in equation 1 or in equation 2 to obtain the velocity. Let us put it in equation number 2. It is u square sine 2 theta by g is equal to 2 into 78.4. So putting theta as 45 degrees, we will get u square sine 90 degree by 9.8, which is equal to 2 into 78.4. So from here we will get u as under root 2 into 78.4 into 9.8, and when we will calculate this, we will get it as 39.2 meter per second. So in order to calculate the velocity of projection, we have first calculated the angle of projection, that is 45 degrees, and then we have put down this value in second equation. You can put in equation number 1 also in order to calculate the velocity, and we have find that velocity is 39.2 meter per second. Now let us solve question number 3. From a point on the ground at a distance of 15 meters from the foot of a vertical wall, a ball is thrown at an angle 45 degrees which just clears the top of the wall, and afterwards it strikes the ground at a distance 5 meters on the other side. Find the height of the wall. See, here it is given that the ball is projected at an angle 45 degrees. This is 45 degrees with initial velocity u. The ball just covers the vertical wall of height which we have to calculate. Suppose this is the vertical wall. Let its height be h. After striking the vertical wall, the ball reaches to a point. Let that point be represented by B. That means it is written that after striking the top of the wall, the ball covers a horizontal distance of 5 meters. Now let the point from where the ball is thrown is marked as A, and the distance of this point from the vertical wall is 15 meters as is given in the question. So from the figure only we can find the horizontal range. The horizontal range as given is 15 plus 5, that is it will be 20 meters, and it is clear from the figure. So let us put the formula of the horizontal range. It is u square sine 2 theta by g, which will be equal to 20. Theta is already given to us as 45 degrees. So it will become u square by g is equal to 20. Mark it as equation number 1. Now let the top of the wall be represented by the coordinates x, y. So, and this be the coordinate axis like this. Then x will be equal to 15 meters as we can see from here, the distance from the point A where it is marked as origin, and we have to calculate y, which is the height of the vertical wall. Now let us use the equation of trajectory, which is y is equal to x tan theta minus half gx square upon u square cos square theta. Y is h, x is 15, theta we know it is 45 degrees, so it will become tan 45 minus half g x square, that is 15 square, upon u square, that we can find from equation number 1, that u square can be written as 20 g into cos square 45 degrees. So after solving this we will obtain tan 45 is 1, so we will get 15 minus half 15 square by 20 cos square 45 degrees, so it will be 1 by 2. After solving this we will get as 3.75 meters. So the height of the vertical wall is 3.75 meters. Now let us solve last question. A body is projected with a velocity of 40 meters per second. After 2 seconds, it crosses a vertical pole of height 20.4 meters. Find the angle of projection and the horizontal range of the projectile. That means we have to calculate theta as well as range r. It is given in the statement that after 2 seconds, the body crosses the vertical pole, which is shown by like this, that u is equal to 40 meters per second and the vertical pole, suppose the vertical pole is here, which is at a height of 20.4 meters, and the time taken by the body to cover or to cross this vertical pole is given by 2 seconds in the question. So now if you look carefully, what will be the vertical component of the velocity? 40 meters per second is given. So the vertical component will be 40 sine theta. Because here it is given that it simply crosses the vertical pole. It is not mentioned that this is the maximum height reached. So we will consider the velocity as the vertical component. And acceleration will be minus 9.8 meter per second square. Time is given as 2 seconds. So here y is 20.4 meters. So we can use the equation as y is equal to ut plus half at square. Now the vertical distance covered is 20.4, which is equal to vertical component of the velocity is 40 sine theta multiplied by time 2 seconds plus half acceleration is minus 9.8 and time is again 2 seconds. So let us solve it to obtain the angle theta. It is 20.4 and when we will solve this expression we will get it as 19.6. So putting it on the left hand side we will get as this expression. Adding the two terms on the left hand side we will get as 40 is equal to 80 into sine theta, or you can say sine theta is equal to 1 by 2. That means theta is 30 degrees. So we have calculated the angle of projection as 30 degrees. Now let us find the range. Range formula is u square sine 2 theta by g. Putting down all the terms, u is 40, so 40 square, sine 2 theta will be sine 60 now by 9.8. After solving we will get as 141.38 meters. So we have obtained the horizontal range of projectile. Thanks for watching. Please like, share and subscribe.